Hi, I am Rachel Acker, and I am in Dr. Prowell's 3D printing class for Biomed 380. And this is my project. I came up with a countertop vertical herb garden. Can't really tell in this photo right here, but luckily it is right here. It's got these 4 holes right here. Got a drawer that pops out. A little background on the project. Urban agriculture is getting pretty popular, just as far as you can maximize growing yields while minimizing surface area, which is really important in urban communities. I wanted to take those same principles and apply them in my very own kitchen. Alright, so the purpose of my project was to design, draw, and print a vertical plant bed that was designed to fit in my kitchen using recycled water to grow the herbs. So I'm an environmental engineer, so this whole kind of project was new to me. I touched CAD briefly, however I was able to relearn Creo to draw the parts and continue on the process that way. So the design goals were to have a vertical garden that grew at least 2 different herbs. So that was the purpose of each of these individual components, having those 2 holes with a separator in the middle. We'll get into that a little bit more later. But also I wanted to be able to capture the water at the base of the structure and have a way to recycle it back into the system. Additionally, I wanted to be able to add more growing space in order to increase crop yields. So just in case I wanted to grow basil, oregano, thyme, and who knows what else, just add more. So, as far as the base of the structure itself, took a couple iterations, but basically it came out with a pretty simple system. I've got a shell with a hole cut out on the top, and a pan with a handle, so the pan just slides right in, and that's designed to capture the water, remove it, and then add it to the top of the system again. So that is neat. And then, every time. And then, so in the top of the system, we have these little plant beds. So you'll notice in this in this picture right here, no you can't, there's a wall separating the 2 sides of it. So one thing that I was taking into account was to be able to have these little feet be able to fit in the next container and be safe so it wouldn't wiggle too much, and then also just be able to be stackable. Some cool project features, just the fact that it is stackable, with the ability to be added on in the future, or removed if crop doesn't do so well. Another awesome aspect is just the fact that you are able to capture the water at the bottom of your system, so therefore you're recycling it, you're using it, it doesn't just seep out and evaporate, you're able to contain it and reuse it. Also, there's a child lock due to the feet on the bottom of the plant beds. The drawer is not able to slide out too far. So that would be great in case it gets knocked or shoved on the kitchen counter. It won't fly out and saturate your kitchen. So what I learned, besides Creo and the whole 3D process, measure twice, cut once. So there are a lot of things that didn't go quite right, where it looked like it was drawn right, and then for some reason or another, just didn't quite fit. Another thing that I learned was sometimes it made more sense to print things upside down. So originally the top piece was a little bit different, but I created it like this, therefore it printed the top first and then printed up, so therefore I wouldn't need supports. It looks really great. The only problem is that the top, which actually would be visible, looks not so great. Contrary to that, so then I learned to print it upside down, so the bottom, which isn't seen, actually looks alright, and then the top looks a lot better. So without sanding it, we're able to make that piece look a lot better. Also takes a lot longer than you think, and uses a lot more material and filament than you think. For instance, this base shell that I showed you earlier, about 12 yards of material, which to me still doesn't make sense, but it's there. Every time. Another mistake that I made was in the original drawing. Just had this great idea of having a pan that would go into a container, and somehow or another I was thinking of woodworking joints, and I'd have to create this handle that would go on this base, and I would slide it in and glue it in. But two things went wrong with that. One, I forgot a piece. So even if this handle did slide in super well, there's still no outside perimeter to rest the top on. Two, I did not allow for tolerances, so these don't fit. Even if it were a perfect world, I didn't really take that into consideration the first time. So like I already talked about printing some parts upside down and just kind of the aesthetics of that. And then stackability, as far as what I've shown earlier with this little barrier in between the top compartment and the second in the bottom compartment. This one originally had a very shallow depth, so therefore when being stacked they actually didn't sit quite right together, so that was lowered for the second generation, so therefore they are able to sit in each other. Things I would change, 100%, I would get rid of the safety feature. That was a mistake. So I went from going from this base that had an extra little height to it, to that would be comparable to the foot, to no extra material, so it kind of got stuck in there. Not the worst thing in the world, but obviously not what I wanted. And then also, again, I would lower the barrier of each stackable planter, and that would allow for possibly a brick type configuration, so, and then lower this part as well. Originally they were kind of dual octagons. The final ended up being a single octagon. So if we were able to lower that, then we could do something like a brick pattern and have this go over here and over here. Just kind of mix it up a little bit so it's not all just straight up. It's like Legos, but for agriculture. And that's it. Thank you very much.